GCC, this will be our last of the Chapter 10 videos. It'll be a long one, but we're going to finish up the chapter in this video. We're going to talk about double replacement reactions now. You'll need your periodic table to look up solubility rules and charges, so have it handy. So a double replacement reaction is when we have a metal with a nonmetal, like M1X, and we have another metal with a nonmetal, like M2Y. And we have a double switch. Metal 1 and metal 2 switch places with each other, so it's a double switch, double replacement. M1 goes with Y and M2 goes with X, and one of those needs to be a solid. This is called a precipitation reaction when a solid forms. The solid product is called a precipitate. If a solid forms, the reaction occurs. If we do not have a solid form, it's actually a no reaction, as nothing changed. All the ions are still soluble and remain floating around. So metal 1 and X are floating around in solution. Metal 2 and Y are floating around in solution. When you pour those solutions together, it's metal 1 and the Y that find each other, bond, stick in the solid, and sink to the bottom. They precipitate out, and they're a solid. That's why it's a reaction, because those two ions find each other and stick together and sink to the bottom as a solid, whereas M2 and X just continue floating around. Here's our first example of a double replacement reaction. We have barium nitrate, aqueous, it's soluble, and magnesium sulfate, also soluble. So they're both soluble, meaning barium's floating around, a couple of nitrates are floating around, Mgs are floating around, and sulfates are floating around. They're all floating around. We pour them together, and let's see if any of them precipitate out by making a solid. So we're going to put barium and sulfate together. Let's check the charges. Barium's a +2. Sulfate is a polyatomic ion. Let's look it up. Sulfate is a -2. So +2 -2 adds up to 0, so it's BaSO4. Great. Now the Mg and the NO3 are going to come together, maybe. So Mg, check the charges. Mg is a +2. Nitrate is a polyatomic ion, and it's a -1. That doesn't add up to 0. Mg is a +2, nitrate's a -1. We're going to need 2 nitrates to go with an Mg. So the formula will be MgNO3 twice. And hang on, let's then look up the solubility rules for those. So barium sulfate. We're looking for barium or sulfate, whichever we come to first. Barium or sulfate. Sulfate, rule 5. Sulfate is typically soluble, but calcium, strontium, barium sulfate are insoluble. So barium sulfate is actually going to make a solid, so we are going to have a reaction. Let's go ahead and check on the magnesium nitrate. Magnesium or nitrate, whichever we come to first. Nitrate, rule 3, soluble, no exceptions. So the magnesium nitrate gets an AQ, the barium sulfate gets an S. There we go. We're going to produce barium sulfate solid, magnesium nitrate aqueous. Because we made a solid, it's a reaction, it's a go. Let's balance this, and remember, keep your polyatomic ions together as a group. We've got 2 nitrates on the left side. We've got 2 nitrates on the right side. We've got 1 sulfate on the left side. We've got a sulfate on the right side. We've got 1 barium, 1 barium, 1 Mg, 1 Mg. My gosh, this one's already balanced. That's shocking. You won't see that on an exam or a quiz. So you need to know how to balance your reactions. This one was already balanced. Remember to balance polyatomic ions as a group if they're on both sides of the reaction. Don't separate them into atoms. So don't do S with 4 O's. It's 1 SO4. Balance them as a group if they're on both sides. Let's try another one. We got some lithium carbonate soluble aqueous and some magnesium bromide aqueous. So we got lithium's floating around, carbonate's floating around, Mg's floating around, Br's floating around. Let's see if any of them, when we pour them together, come together, stick, and sink. So who's going to come together possibly? Li and Br. Okay. Li is a +1. Br is a -1. +1 -1 adds up to 0. So LiBr is one possible product. Then we have Mg, which is a +2. CO3 is a polyatomic ion. Let's look up its charge. It's a -2. Wow. Mg is a +2, CO3 is a -2. 2 minus 2 is 0. So MgCO3 is the other product. Now we need to look at the solubility rules. So LiBr, we're looking for Li or Br, whichever we come to first. Rule number 1 is Li, soluble. So that gets an AQ. So far we didn't make a solid yet. What about MgCO3? Let's look up Mg or CO3, whichever we come to first. Aha, rule number 6, carbonate, insoluble. There's our solid. So Mg3CO3 makes a solid, so we do have a reaction. We made a solid. So the products are MgCO3 solid and LiBr. Balancing it, we had 2 lithiums to start with, so we need 2 in front of LiBr. That's good because we have 2 Brs to start with, and now we have 2 Brs as well. So that 2 balances out the reaction. Perfect. There's another double replacement reaction. Good job. Last one. I want you to try this one on your own. I want you to switch partners, check charges, check solubility rules, and balance. Okay, I want you to do all that on your own. Please pause the video and give this a try. Hit pause now. And we're back. Hopefully you got this answer. BaCl2 aqueous plus 2 AgNO3 aqueous makes BaNO3 twice. We need 2 NO3s to go with the barium. Charges, charges, charges. And solubility rules, nitrate or aqueous. And we're going to make 2 AgCls. Ag is a +1, Cl is a -1, AgCl. It's a solid because solubility rule number 4, chloride is soluble except when it's with silver. So it's a solid with silver. All right, so we made a solid, so we had a reaction. So we did have a precipitation reaction here. Again, make sure you pause if you need to look over this more closely. Good job. All right, here are 5 reactions. I don't want you to finish them, although you should be able to. I just want you to tell me what kind of reaction they are. What type of reaction do we have? So hit pause and look at these. Tell me what type of reaction they are. Pause. All right, number 1 is an acid-base reaction. We have an H in front of H2SO4. We have an OH in back of the CaOH2, acid-base. Number 2, we have a single metal, Mg, single replacement, single metal. Mg could replace the zinc. We don't know. We have to check the activity series. But as soon as you have a single metal by itself, it's single replacement. C3H6 gas plus O2 gas. Aha! Oxygen can support a flame, fire, combustion. That's a combustion reaction. Number 4, we have an acid and we have a single metal. We don't have a base, so it's not acid-base. It's single replacement. We have a single metal, single replacement, single metal. Number 5, metal plus a non-metal group and a metal plus a non-metal. Double replacement. Hopefully you did a good job with those. What type of reaction are these? Very important question.